Okay, that is as good as it's going to get tonight. That is a little Dave Brubeck song for you there. So, for today's class, what we're doing is a review of the bilateral deficit, Golgi tendon, organ, and muscle spindle. I'm going to introduce the topic of cross-education. So this is another neurophenomenon. And then I'm going to talk about nervous system anatomy and apply that to rehabilitation from spinal cord injury and types of movements. So voluntary, reflexive, and rhythmic movements. So some multiple choice questions for you here. The bilateral deficit occurs if the amount of weight you can lift using one limb is greater than 50% of the weight you can lift with two limbs working simultaneously. This answer is true. So this would indicate that you're stronger if you lift a weight with one limb. That limb is stronger than if it's contracting with the other limb at the same time. And that's basically the bilateral deficit. For some reason, you have a deficit of strength when two limbs are contracting together compared to when the limbs are contracting one at a time. Which of the following would enhance force development? So we have activation of agonist muscles, inhibition of antagonistic muscles, inhibition of the Golgi tendon organ, or all of the above. The answer here is all of the above. All of these things would enhance force development. Activating the muscle spindle in the hamstrings will excite the motor neuron innervating the hamstrings, inhibit the motor neuron innervating the quadriceps, or all of the above. The answer here is all of the above. So the important thing to note here is that activating the muscle spindle will not only have an effect on the motor neuron innervating that muscle, but it will also inhibit the motor neuron innervating the antagonistic muscle, in this case the quadriceps. Activating the Golgi tendon organ in the quadriceps will excite the motor neuron innervating the hamstrings, inhibit the motor neuron innervating the quadriceps, or all the above. The answer here is all of the above. So just like on the last slide, the Golgi tendon organ not only has an effect on the motor neuron innervating its muscle, which is inhibition, but it also activates the antagonistic motor neuron. Now I'm going to get into a new topic here called cross-education. And this is another neurophenomenon, or more evidence that the nervous system is involved during exercise training. So cross-education refers to the increase in strength of the untrained contralateral limb after unilateral training. So contralateral just means the opposite limb, either in the upper body or in the lower body. And this is caused by altered nervous system activation. So essentially this involves training of one limb over weeks or months, and you will see an increase in strength of not only the trained limb, but also the contralateral limb. So what's happening here is that with cross-education, in this example, you're training the right arm over weeks or months. And when you train your right arm, as represented in the green, you activate the left side of your cerebral cortex. So your motor cortex on the left side activates the right side of your body. What happens when you train one limb is that activation on in this case, the left side of the brain will cross over to the right side of the brain, so you get some training effect on the untrained limb. And the training effect on the untrained limb is about half of what you see in the trained limb. So for example, if you were able to increase your strength by about 50 pounds with your trained limb, this untrained limb would see an increase in strength of about 25 pounds. So it's got to do with perhaps the way the motor cortex is activated when you activate the left side of the motor cortex to activate the right side of the body, the right side of the motor cortex gets some of that, can read some of that activation, and you get a training effect in the untrained left arm in this example. The magnitude of the strength increase in the untrained limb is proportional to the strength increase in the trained limb. So the more you have a strength increase in the trained limb, the more you'll have a strength increase in the untrained limb. And as I mentioned on the previous slide, it's about 52% of the strength of the trained limb. So the untrained limb will increase to about half the strength of the trained limb. And the cross-education effect is greater if the task that you're training with is more novel. So a more unfamiliar task will elicit a greater effect of this cross-education.